ray optics. So in previous classes we have studied about the theories, explanation, derivations and formulas of ray optics. So in this class we brush up our concept through these questions, through these numericals in the form of Pyqs. So one by one we are going to solve as many as questions in this session. So my only suggestion is to you that please pause this video and try this question yourself and then only watch my solutions. So this is as better as you do. So from first question, this is the PY, this is the game of 2019 question. So please read it once. A convex lens of focal length 20 cm means you have given focal length of convex lens. So the best approach of solving this question is, first of all, write down the data. Write down the data of giving this question. That focal length of a convex lens is equal to 20 cm. So write down the data. Solution number 1. Given what you have to give it, focal length is around 20 cm. So can produce an image of the same magnification 2. What the value of magnitude of magnification, that is 2. As you know very well, magnification is nothing but the ratio of image distance to the object distance with relative sign, and the value of it is 2. As you know very well, in case of convex lens, this is the case of convex lens. In the case of convex lens, your magnification is either positive or negative. It depends on the image form. Means which type of image is to be formed. If your image is to be virtual, then in this case, in a particular case, this type of image, when your image is to be virtual, in this case your magnification should be positive. Write down for a whole load. So before solving this question, let us learn the concept that when your image should be virtual and erect. So in this case, then your magnification should be then the value of magnification. Magnification is always positive. Always positive. Similarly, when your image is real and inverted, then in this particular case, then the value of the magnitude, the value of magnification is negative. Is always negative. Always denote, or you have to write with the negative sign. I hope this clear you. These two notes are very helpful before from this question, because this question entirely depends on the value of magnification. So please repeat it again. When your image should be virtual and erect, I can tell you one thing. In a convex lens, your magnification can be either positive or negative. So it depends on the image formation, which type of image. So in this particular case, your image is virtual. Image is like virtual and erect. So in a particular case, in this case, we are treated the magnification with a positive sign. Similarly, when your image is to be real and inverted, so image should be real. In this particular case, your magnification should be treated with a negative sign. So I hope it is clear to you. So in this particular case, when your magnification is 2, of the same magnification. So the question is, question tell to you that magnification in both the cases will 2, but it doesn't say it should be positive or negative. So according to your concept, you have know very well that when x1 is nothing but the object distance. x1, let us suppose x1 is the object distance when your image is to be real. So in a particular case, when your image is to be real inverted, then in this case your magnification is negative. So in this particular case, when x1, we have to treat the object distance when your image is real. So we keep magnification as what? Negative sign, means -2. So put the value and get your answer. So please create a box, and as you know very well, for a particular case, let us say that x1, write down the value of x1. x1 is nothing but the object distance. What? x1 is the object distance. x1 is the object distance. When image is real. Or we say inverted. Similarly, x2 is the. I hope it is visible to you. So x2 is the another object distance. When your image is virtual. I hope it is clear to you. Means x1 is u1, object distance. Similarly, x2 is the u2, object distance. But in this case, image is virtual. x1 is the object distance. In this case, image is here. So in this first case, so when your x1 forms a real image, x1 is the object distance and it forms a real image, then in this case your magnification becomes negative. So now the value of magnification becomes -2. And you know very well there are two formulas in convex lens of magnification. So whenever we establish a relationship between focal length and object distance, then in this particular case the formula of magnification becomes f plus u, where m is the magnification, f is the focal length, and u is the object distance. In a similar way, when we have to establish a relationship between focal length and image distance and magnification, then in this particular case the formula of magnification becomes like this: m is equal to f minus v upon f. I hope this clear. These are the two main formulas which we have to use later on. So in this case we have u means x1, similarly object distance. So I hope this clear to you. We do not use this formula of magnification because we don't have image distance. I hope this clear to you. So what this formula? We have to use only this formula. And where m the magnification, m is the focal length, and u is the object distance s1. So write down the value of m here. M is equal to -2. M is focal length. What is focal length? 20. Write down the value of f 20 plus u. One more thing I can tell you the guys, in a convex lens the object distance always be negative, but we don't have the magnitude of object distance, so we don't put any value of u. So just solve this equation and get your answer and find the value of u. Let's suppose this is the u1 or we say the x1. So it becomes -40 minus 2u1 equal to 20. So 22 minus 1 goes here, it becomes +1, minus 40 minus 20 is become -16. The value of u1 becomes -30. I hope this clear to you. So u1 is nothing but this is the object distance. This is the object distance when your image is to be virtual. u1 is nothing but the x1. So whenever we have to consider the distance of image, then it is always positive. We have to only consider the magnitude of the image, magnitude of the distance. That so write down here. This is the x1. When we have to calculate the value of x1, is the mod of u1. So remove minus, it becomes 30 centimeters. So similarly, x1. Now we have to calculate the value of x2. So we make a second case, that is, I hope you have noted it down. So in this case, your image will be virtual. In first case, your image is real. When your image is to be real, we take the sign of magnification is to be positive. No, when your image is real, sign of negative. But in this case, your image is virtual. Then your magnification should be what? What? Positive. Yeah. So in the second case, when your now it's time to this x2. x2 is nothing but the mod of u2. And what the x2 is the image distance. Image distance when your x2 forms a virtual and erect image. Virtual and erect image. Then in this particular case number 2, the value of magnification is always be positive whenever the image form is virtual. So in this particular case, magnification should be positive. So as you know very well, the formula of magnification becomes f over m plus u. So substitute the value of magnification, total length and u. This is not u, this is u2. Now it becomes u2. So now it becomes object distance, the image should be virtual. So substitute the value and get your answer. So in this particular case, substitute the value of magnification, that is 2 is equal to f. F means focal length, that is 20 centimeter. 20 upon 20 plus u2. So this equation that becomes 40 plus 2u2 is equal to 20. So 2u2 is equal to minus 40 plus 20 is equal to minus 20. u2 becomes 10, minus 10, not 10 minus 10. So again I can tell you one thing, that u2 is nothing but the object distance, and whenever we have to calculate, we have to find the object distance, the magnitude, we have to take the magnitude always be positive. So u2, so here x2 becomes mod of u2. So the object distance, we have to calculate the object distance. The object distance u2, when your image is in virtual, is nothing but the positive 10. So now we have to, the question has asking the ratio of x1 and x2. So now the ratio becomes x1 by x2. Now this time x1 is 30 upon 10, that becomes 3 by 1. It is equal to 3:1 ratio. So your answer is 3:1. So in the right answer, your answer is 3:1. So this is your entire solution of this question. I hope it is clear to you. So question is not very tough. It is moderate question, moderate type question. So before solving this question, you have to remind some of the things, that in a convex lens always produces a virtual and real image. And whenever we have to treat the magnification sign, then it depends on, magnification is either positive or negative. It depends on the image formation, as you know very well in a convex lens. So in this particular case, when your x1 is nothing but the x1. What is the x1? x1 is nothing but the object distance. When your image is real, in this particular case, the magnification, we take the magnification sign as negative. Second case, when your image should be virtual, then in this particular case, the magnification should be positive. And one more thing, here a relation between x1 and x2. What do you mean by this? This means x1 is very far away from the optical center. As you know, the size of x1 is very big. x1 is big and x2 is small. That means x1 is kept at very far away from the optical center. Similarly, x2 is placed at a very short distance. I hope this is clear to you. So this is all about first question of the image. Now we are trying to solve our next question. So please do it fast. our next question, please move it fast. Our next question is, our next question is, the diameter of a plano convex lens. Write down the question. Diameter of a plano convex lens is. Now we have to draw a plano convex lens, and the diameter is given 6 centimeters. What? Diameter is all about. Write down the question. Diameter of a plano convex lens is 6 centimeters, and thickness of the center is 3 mm. Like this is the plano convex lens. Simple. Take convex lens. This is like this. This is plano convex lens. Okay. Write down the question. Diameter of plano convex lens is 6 cm. The thickness of the center at the center is 3 mm. With the speed of light of the material of the lens is 220 10 to the power 8 meter per second. Now the question is asking the focal length of the lens. What? The question is asking the focal length of the lens. As you know very well, this is a part of no scale like that. So we can make a type of spiral surface around it like this. So it is very easy now to dictate the things. So this plano convex part of those scale is like that. So this is the center of this spiral surface, entire spiral surface. And you know very well the diameter. What? The question is in the question, the data given the diameter of plano convex lens means this is around let's suppose this is around 3 centimeters. Why? Because this is the diameter. Your diameter is this is your entire diameter. This is also 3 centimeters because from here to here it is 6 centimeters. In this question, the diameter of a plano convex lens is 6 centimeters. So your radius R is nothing but the radius. So radius becomes 3 centimeters. Radius half of diameter. Again, the thickness of this thickness at the center is 3 mm. Means this is given the thickness at 3 mm. Thickness at the center. This is given 3 mm. Thickness. How much? This plano convex lens. How much it is thick? It is 3 mm thick. So, and one more thing that the speed of light of the material of the lens means mu surrounding. That is 2 into 10 to the power 8 meter per second. This question is very interesting and very good question. So, in this question, we have to calculate the focal length of the lens. Now we have to calculate the focal length of the lens. So, solution point. So, we try it once and then see what my solution is. So, it is much better to you. So, the best way to solve this question is to solve step by step. First of all, as you know very well, whenever we have to calculate the refractive index is nothing but in step 1, we have to calculate the refractive index. So, write down the step 1. In step 1, we have to calculate the refractive index. Means, as you know very well, mu is equal to C by V. Means refractive index nothing but the ratio of the speed of light in vacuum to the speed of light in the material. So, substitute the value that now the velocity V is equal to C upon mu. Mu you have to come value something. US. Take the 10 to the power 8 upon 2 to the power 8. Cancel out. V by 2 that is around 1.5. I hope this is clear to you. I hope this is clear to you. Any doubt? Anything? Yes. So, we have a value of refractive index mu. No, this is the value of. Now substitute the value of mu. that is mu, and v, and then the value of, it becomes the value of mu, that is 1.5. So in another step, now we know the value of mu, and whenever we have to calculate the radius of curvature for a thin convex lens, so in particular case, step 2, we have to calculate the radius of curvature. So for a thin lens, the radius of curvature is to be calculated by the formula equal to r. What is the formula? It is very important formula, that r square upon 2t, r square upon 2t plus t by 2. This is a particular formula we have to use when we have to calculate the radius of curvature for a thin plano convex lens. So in a particular case, whenever we have to calculate the radius of curvature for a thin plano convex lens, so we use this formula. So here r is the radius of curvature of the lens and r square. So you student might be always be confused that between what is the capital R, here what is the capital R denotes and what is the small r. So here capital R denotes the radius of curvature of the lens, whereas small r nothing but the aperture radius. Aperture radius. So as you know very well, here aperture is nothing but aperture is this is the aperture. This total length is the aperture. Means how much it is thick. Now how much it is. This total is the like this is the lens. Suppose this is the lens. This is the aperture. This is nothing but the aperture. The distance between here to here. Means this lens, the open, how much it is to be open. This is the aperture. I think you know very well. And the t is the thickness. Here t is nothing but the thickness of the material. Thickness of the material. So, put the value and get your answer that r is equal to aperture radius. As you know very well, the aperture radius is, I think, 3 square. Absolutely right. Put the value. Aperture radius 3 square. 2 t. Thickness is 3 or we can say 0.3 centimeter plus 0.3 by 2. So after solving this equation, I think this is to be right. So after simplify it, this becomes 9 by 0.6 plus 0.3 upon 2. 20. This becomes 19. So cancel out by 3, 15. So it becomes 20 plus 3. So it comes around 15.56. I hope it is clear. 15.15 for 15.15. It comes around 15.15 and R is centimeter. The value of continuous sine set in the unit centimeter. I hope it is clear. R. Now, as we know very well, since as we know the thickness is very less than the aperture radius. So the thickness is very less than the aperture radius. And as you know from the figure, the thickness is very less. The thickness of the material, aperture radius is great, is big, and the aperture radius is very small. So from this, we have to consider r is equal to 50 centimeter. I hope remove 1.5 because as you know, aperture radius is very big than the thickness of the material. Aperture radius is very big than the thickness of the material. So we can consider only, then we can remove the decimal sign, decimal 2 digit, and we can consider only the real part of this 2 digit. So our next step 8 is to put the formula, that is lens limit formula, because whenever we have to establish all is our relationship between focal length, refractive index, and radius of curvature. So the only formula that fit in the all of the relations with the less bigger formula. So without wasting any time, let's put the value in the less bigger formula and get your answer. So let's remove the result. Using length, that is the one line using the length, make a formula. So your less bigger formula like this. 1 upon r is equal to mu minus 1. 1 upon r1 minus 1 upon r2. I hope this is clear to you. So 1 upon f means focal length. So you have focal length? No. Focal length is all about you calculate this question. Mu, yes, mu you have to calculate 1.5 minus 1. 1 upon r1. R1 means it is very obvious that R1. What is the R1 in this question? R1 is 15. We have to take R1 as 15. R1 is equal to nothing but the R. R1 is nothing but the R means 15. Similarly, R2 is nothing but the infinite. So minus. So 1.5 that becomes 0 like this. So solve this equation. 1 upon f. 1.5 minus 1 will become 0.5. 0.5 into 1.15. That will be 10. 1.30. So your value of focal length is f equal to 30 centimeter. So check the option please. Your option. Your option is 15. These are your options. These are your four options. 15 centimeter, 20 centimeter, 30 or 10 centimeter, 30 centimeter and 10 centimeter. So check the option and write your answer. Your answer is 30 centimeter. So your answer is option number C. So the question is easy. Only you have to understand something that if diameter is given, so first you have to calculate the radius, and if your thickness of the material is given, so you have to study the relationship between focal length, refractive index and radius of the meter by the length formula. And first of all, if the refractive index of surrounding is given, you know very well mu is equal to C by V, means the speed of light reflecting upon visible light in other medium, speed of light in other medium is this is not V. Yes, this might be some, this is V. So in this question we have given V is equal to 2 to the power 8. So put the value of V and get your answer. I hope it is clear to you. This question is very simple. So our next another question. So write down question number 3, that 2 lenses power minus 15 diameter. That is the question. We have 2 lenses. We have 2 lenses and the power is given. First the lens, the power of first lens is minus 15 diameter. Minus 15 diameter, and the power of lens 2. The power of lens 2 is to be given as the power of lens 2 is to be given as minus plus 5 diameter. Means you have given 2 lenses power. So solution number 3 means in this question the best approach to solve any question is that firstly you have to write out the data given in this question. Then after you have to think from which concept the question is to be solved, or you put any formula or substitute any type of equation related to this question. So this is the best possible approach to solve any type of question. So first of all, write down the data. So whenever you are trying to solve any question, first of all you have first and foremost put down the data means in this question we have two powers, -15 and +5. I hope this is understood to you. The focal length of the combination. So as you know very well, so here it is asking focal length. Focal length of the combination means effective focal length. So there are two methods to solve this question. First of all, as you know very well, power is nothing but the inverse relation of inversely proportional to focal length. P is directly proportional to 1/f. So you have directly calculated the focal length one by one, or first you have to add the power, total power, and then calculate the total focal length, combination focal length. So the P effective means total power is P1 plus P2. That becomes nothing but -15 at the +5 diagonal. So it is about -10 diagonal. So now we have to find the focal length of this relation, as we all know that power effective बराबर 1/f effective. It is the power of total component to power 1 and power 2, means is the effective power of both of the two powers and the total focal length of both of the powers. So effective becomes directly proportional to 1/P effective. So P effective becomes 1/-10. So it becomes the approximate -0.1. So is your answer? No. You have to multiply it with 100 to convert it in centimeter. Because power is always you have to calculate it in centimeter. So it becomes -10 centimeter. So there are the four options, as you know very well. +10, -20. We have the four options of the question. +10, -20, plus -10, -20, +20. So pick up the right options. That your -10 means that your correct answer. Option number C. I hope this clear to you. So write down the next question. Question number. So a double convex lens. Write down the question. A double convex lens has power P. We have double convex lens. So the power P and a double convex lens has power P and same radius of curvature R of both the surfaces. Means you have double convex lens, which is the magnitude of power, that is P, and also you have the radius of curvature R of both the surfaces. So in this question, the radius curvature of a planar convex lens and made of the same material with a power 1.5 is. I repeat it once again. A double convex lens has a power P and same radius of curvature R of both the surfaces. The radius of curvature of the surface of a planar convex lens with the same material with a power 1.5 P. So in this question, you have to only solve the equation and get your answer. It is so simple as that. So let us understand this question and question first. So as you know very well, the relationship between power and focal length is inverse relation, or P is equal to 1/f. And in this question, we have also given the refractive index, mu. So, and the question is also asking the radius of curvature. Means the question is we have to calculate the radius of curvature. So I can tell you in previous question that the only formula which can establish the relationship Newton formula. So your less weighted formula nothing but 1 upon f mu minus 1. It is mu denser or mu layer 1 upon r1 minus 1 upon r2. So this is the formula of less weighted, is the less weighted formula, and you know very well we have power. How much power it is? 1.5 P. So substitute the value and get your answer. First of all, we have to know that R is equal to R. First of all, you know very well कि 1 upon f is nothing but 1 upon f is equal to T. So we can substitute T here. T is equal to mu minus 1. And one more thing, that R1 is nothing but that is simply R, and R2 is nothing but the minus R. I hope this clear to you. So after solving this, you have to get the value of power, that is 1 upon R plus 1 upon R, that is 2 upon R, that is R by 2 means mu minus 1. That is 1 upon R plus 1 upon R, that is 2 upon R. Or we can write it as, you know very well, f is equal to R by 2. So we have to layer f. So it becomes P is equal to f mu naught minus 1. I hope you are right. Or we have to put this value as equation number 1. Right here, equation number 1. So now we have to calculate another formula for P dash, that is. So from this question we have power is equal to 1.5 P. P2 is 1.5 P. So again put the less weighted formula for second order less. We see in this question we have double combinations now. So now put this formula for second order less. So substitute the value and become power P2 mu minus 1. Substitute the value of P2, that is minus 1.5 P. I will go over 1.5 is similar to the value 1.5 P. And that 1.5 P mu minus 1. Upon R1 minus 1 upon R. So, in the second equation, and here R2 is nothing but R2 tends to infinity, and R1 is R1 dash, it becomes R1 dash. So, R1 dash. So after solving this equation, we can get mu is equal to, we can get eventually P dash is equal to P dash of 1.5 P, either you have to use P dash or it is equal to mu dash minus 1. It is not mu, now it becomes mu dash, changing mu. So it becomes P dash is equal to 3 by 2 P. So whenever we have to divide this equation with this equation, so we can get the value and substitute this value in equation. So it is very easy to use. So the simple way, mu minus 1, and later on we can put the value of R dash here. Similarly, becomes mu2 minus 1 3 by 3. So here this 2 by r. nothing but your correct answer is R is equal to R by 3. This is your right answer. So in this question, the question is asking about the radius of curvature. So this is your radius of curvature. The second becomes 1.3 times of the 1.3 times of the given radius. I hope this is clear to you. Now we have to solve another question. So right now question number, if area of bicycle of minimum dimension like incident or twist, like this is the question number 3. This is your twist like this. Area of light incident on it. This is your twist. So area of light strikes on it like that at an angle of incidence. This is your angle of incidence. This is normal. Means the incident angle is nothing but the incident light and the normal. The angle between the incident light and the normal is called the angle of incidence. So the question is, or the question is saying, the ray of light of minimum dimension when incident on the prism. Is there a prism? Having angle of prism equal to 60 degree means this is given angle of prism. This is nothing but the angle of prism that is 60 degree. So the refractive index of this material is under root 2 means mu. Mu of the place is nothing but the under root 2. I hope this is clear to you. So the angle of incidence in degrees. So we have to calculate the angle of incidence. We don't have the value of, we don't have the magnitude of, in this portion, the magnitude of incidence or angle of incidence is not given. So as we know very well, whenever we have studied the concept of refraction to a place, then a incident ray strikes on it at some point. So whenever a ray passes from rare medium to denser medium, always it bends towards the normal. So it is normal. So it bends like that. It is normal. It bends towards the normal. And whenever ray, this is the normal. So this is nothing but this is the normal. So whenever a ray strikes from denser medium to rarer medium, so always it bends away from the normal. This is normal and it bends away like that. This is the basic concept of refraction through a place. So this is the incident ray. This is nothing but the incident ray. This is refracted ray IR. This is the emergent ray here. So the angle of incidence is the angle between the incident ray and normal. The refraction angle is the refraction angle, and this is your the angle between the emergent ray and normal is called the angle of emergence. I hope this is clear to you. So this is the basic concept of refraction through a place. But in the case of minimum deviation, this is a very special case. This is a very special case of minimum deviation. Special case. So in a minimum deviation case, like this is the place, again take here, this is the place. Your angle of place in this case same angle of place is 60 degree. So whenever a ray of light strikes on it, this is the normal. So in the case of minimum deviation, the light should deviate minimum. Means there is deviation in the light, but it is very minimum. Means the light ray goes parallelly like this. Means whenever a light goes near medium to denser medium, it bends towards the normal. So it bends, but very limited. I hope you understood my concept. That so in the case of minimum deviation, the light ray goes parallelly towards this, and this is the your normal. And now it bends. Whenever the ray of light goes denser medium to rarer medium, it away from the normal. So it goes like like that. This is the angle of incidence. So we have to calculate the value of that angle of incidence. This is the angle of emergence, and this is nothing but the deviation minimum. This becomes not deviation. This becomes deviation minimum. In this case, the deviation is only deviation, but in the case of minimum deviation, deviation becomes. So there are some cases like deviation becomes deviation minimum. So first of all, you write R1 becomes R. Similarly, R2 becomes R. This is the R1 and this is the R2. So the value of R1 and R2 becomes R here. Similarly, angle of emergence becomes angle of incidence becomes angle of emergence. So we have to, if the question also asking the angle of emergence, so if you have the value of angle of incidence, then automatically it is equal to the angle of emergence in a minimum deviation case. Similarly, deviation minimum becomes deviation minimum. So one important formula, as you know very well, angle of deviation minimum is always equal to the angle of emergence. So it is deviation, so angle of emergence plus angle of incidence plus angle of emergence. You know this relation, I think. I can write this also. Means this is the angle of deviation is always equal to the angle of incidence plus angle of emergence. So as you know, in the minimum deviation case, deviation becomes deviation minimum. Angle E becomes angle I. So it becomes 2I A plus deviation minimum. So I is equal to A plus deviation minimum by 2. So this is the value of angle of incidence. So we have this is the format. If we have find these terms in this format, so this automatically this is equals to the value of angle of incidence. So as you know very well, there is a formula. So as you know very well, the refractive index always equal to the refractive index, and this is the very important formula. Sine of angle plus deviation minimum sine of A by 2. Both please use this formula of refractive index. That is a very important formula. Learn this formula, so it is a very important formula, and you can put this formula and get your answer. So we have what? We have value of envelope, substitute this value, but we have not substitute the value of envelope here because this is the approach. This is the basic approach to solve this question. Because if we change this format now, so here there is no term of angle of incidence. So if you find the value of magnitude of this entire term, so it automatically equals the magnitude of angle of incidence. So put the value of angle of incidence only here, and we have also the value of refractive index, that is x √2. The value of only comes sine of, don't change this format, sine of A by 2 means A means angle of is nothing but 60 by 2. Angle of 60 by 2 means 30 degree. As you know, means sine 30 degree is 1.2. Sine of A plus so cancel out. Sine comes here. Side whenever sine comes in left hand side, so it becomes sine inverse. And the sine 1.2 is sine 25. A plus deviation minimum. So sine inverse and sine is automatically cancelled out, it becomes 45 degree. So this is the value of A plus deviation minimum 1, 2. And it is equal to the angle of I. So your value of angle of incidence is nothing but 45 degree. So your right option is nothing but 45 degrees. So your angle of incidence is nothing but 45 degrees. So the right ray always strikes at angle of 45 degrees when in the case of remote elevation. I hope it is clear to you. So now comes in the question, that is question number 6. So we have solved 5 questions. Now we have to solve 6 number questions. So that is the question number 6. It is very easy. That is the question number 6. What is the relative decrease in focal length? What is the question? What is the relative decrease in focal length? Means we have calculated decrement in focal length. What is the relative decrease in focal length? This is question number 6. What is the relative decrease in focal length of a lens for an increase in optical power by 0.1 diopter from 4 to 2.5 diopter? This is question number 6. So I repeat it once again. What is the relative decrease in focal length of a lens for an increase in optical power by 0.1 diopter to 0.1 diopter from 2.5 diopter? So it is very easy question. So first of all, you have two values. P1 is equal to 0.1 diopter. Question number 6. So in this question, P1 means 0.1 diopter. 0.1 diopter. So as you know very well, the relation between power and focal length is inverse relation. So before solving this question, 0.1 diopter. So the value of F1 becomes in the value of power P1. So F1 becomes 1.1. That is nothing but 10. F1 is 10. Okay. Similarly, there is an increment in power. Means P2 is not. So P2 is what the value of P2? So according to the equation 2.5, but no, P2 is not 2.5. P2 is not. P1 is. I create a little mistake that P1 is not a common. P1 is 2.5. P1 is nothing but because 0.1 diopter from 2.5 means the initial value means the value becomes 0.5 diopter. This is your value. So this is the P1. Means this is the total increase. This is the increment. How much it should be increased? 2.5. What? 0.5. This is the 2.5. So it is increased by how much it is increased? We have to find it. How much it should be increased? So P1 is 2.5. P1 is nothing but 2.5. So here P1 is 2.5 diopter. So as you know very well, F1 is nothing but inverse of P1. F1 becomes 1.2.5. So it is nothing but 5 to 10, 5. It is around 1.4 meter. It is not, whenever we have to convert in centimeter, then it becomes 40 centimeter. But there is no need to convert it in centimeter. I think no need to convert it in centimeter. So now P2 is nothing but P2 is nothing but, as you know, whenever we have to calculate the P2. So this is the increment. How much the question is saying, I repeat it once again, what is the rate of decrease partially understood the portion. So your P2 is nothing but the increment. How much it should increase? That 2.5 diameter plus 0.5 diameter. This is the value of P2. So it becomes 2.6 diameter. So again we need the relationship between focal length f2 is equal to 1.2. f2 becomes 1.2 means 1.2.6. So it is around how much is 68, 1, 26 or 7, 2, 2. Again you I hope this clear to you. 8 times. 0.38 approximate 0.38. 0.38. It comes from meter. 0.38. I hope this is able to 0.385. Yes, 0.385. It is around 0.385. So it is the value of, now you know the value of 385 or 38. You write only not 2 places, 38. So now you have the value of f1 and also you have the value of f2 and the question is asking the relative degrees. So you have to find day length. So whenever you have to find the day length means change in f, how much it should be changed. Day length means change in f means f2 minus f1. Simple. So the value of f2 it is not f2 minus it is f1 minus f2 means first of all how much it should be increased from f1 to f2. So substitute the value of f1 here. f1 means 0.4 minus 0.38. So how much it should become? 0.4, 0.38. It is around 2, 1. 0.12 meter. I hope this is clear to you. 0.1. No. 0.4. Zero. Yes. So this I hope this is clear. So now we go to 9, 1 or 8, 3.015. And take all three values after decimal places. So it is easy to solve the question that is 0.015 meter. This is the f, and now we have to calculate the relative decrease. So whenever we have to calculate the relative decrease, so this is nothing but del f upon f1. If the ratio of change in f, how much the change occurs in f means the how much the focal length has to be changed with respect to its original focal length. This is the nothing but the ratio. This is increasing and this is the relative decrement. So this is the value of del f, that is 0.015 upon f1. F1 is nothing but 3.4. So that is 15 upon 400. I hope this clear to you. That's how by beta 5 beta. So 3 by 80. 3 by 80 I think. Yes. 3.154. 154. You take all the values and 0.4. It is around 0.0385. 0.0385. And it is we have approximately 0.4. So if the question is asking the relative decrease in focal length. So the relative decrease in focal length is 0.4. How much it is to be decreased from original, and when it is to be changed, it is around 0.4. It is the approximate value. Exact value is 0.0385. So the question is not very tough. The question is moderate, in the category of moderate category. But I can again revise all this concept. In this question, we have two values of power, P1 and P2. And P1 value is clearly shown in the question, but P2 is not shown in the question. We have to understand the value of P2 because the question is going to tell you that what is the relative degree focal length of a lens for an increase in optical power. Yes, optical power is going to be increased. So the initial P1 initial is 2.5. So 2.5 is increased by 0.1. So P2 becomes 2.6. And you know very well the relation between focal and power is inversely. So we have to calculate here focal length is 1 upon power, that is 0.4. Similarly P2 we have to calculate from this relation. F2 is inverse relation. So the value of F1 is 0.4, F2 is 0.385. So now we have to calculate change in F because whenever we have to calculate the relative decrease, so it is the ratio of change in F with respect to the original focal length. So here is F1 minus F2. So F1 is nothing but 0.4 and this 4 0 you have to put 0 here. So 0.4 minus 0.385, it becomes 0.015 meter. So the rate of decrease is change in F upon F1. So substitute the value of change in F here, and F1 is nothing but 3.40. Substitute the value and get your answer. Your final answer is 0.0385. It is approximately equal to 0.4. So the relative decrease of focal length is 0.4 meters. I hope you have understood the question very well. So again comes the next question. Write down the next question. Next question is very simple. In the JMS, you know right now, this question is asked by JMS in the, this is a question of JMS 2025. This is a question of, I will solve this question, this is a question of JMS 2025. Means this is the recent value. You have solved this question. Question number 6. This question is 2025 question of JMS examination. Now we have to move to our question number 7. So the graph between the angle of deviation, it is also the recent p/2. The question is asking the graph between the ratio of the graph between the angle of deviation and the angle of incidence for a given rectangular space is represented by. Means you have to tell the graph between angle of deviation and angle of incidence. So there are two types of graph. So there are 4 options. So there are basically 4 options like A, B, C. This is the question number 7. C and D. So you have 4 options. So this is the angle of deviation, this is the angle of incidence. So first graph is like that. This is straight line graph. Your second graph is like that. This is the angle of deviation, this is the angle of incidence. Your third graph is like a straight line. And your fourth graph is like that. Deviation. You have the deviation minimum more. No, you have one angle of deviation. So we have 4 graphs, and the question is asking the graph between angle of deviation and angle of incidence. So you have 4 graphs. So you have 4 graphs, and pick one of the right, which is is right among the four. This is the thing that you like. You know how simple it is. So the right option according to you, yes, option number C. No. It is not constant in both the direction. Angle of derivation is a particular area. So this is option number D. What guy is saying option number D? Yes. This is the best suitable graph among the four of angle of derivation and angle of incidence. So this is, first of all, what is decreases? The angle of incidence, angle of derivation decreases, and then it increases. So there are certain values in which we find the minimum deviation. So this is the angle of deviation. This is the correct relationship between angle of deviation and angle of incidence by the graphical form. So for the place, we write the core line. For the place, as the angle of incidence increases, you know angle of incidence is increasing. Right here, angle of incidence increasing. And right on the line, for the place, as the angle of incidence increases, the angle of deviation first decreases. Means first it is very high value and then it decreases. First decreases and then increases. So this is the best suitable graph for the angle of incidence and angle of incidence. Angle of deviation and angle of incidence. One more question I can bring you guys. Your second option is nothing but your question is an astronomical telescope has a large aperture. Why? Why an astronomical telescope has a large aperture? Aperture you know na? This is the aperture, right? This is the plano convex lens, and the aperture is this. How much it is going to open? This is the aperture. So the question is asking an astronomical telescope has a large aperture. Why? In the reason why? Why there is a large aperture of astronomical telescope? Here four options. Reduce spherical aberrations, have your second option. These are the options. These are the options from A to D, from four options. Have high resolution. Your C option is nothing but have increased have more discordant. And your fourth option is nothing but increase span of observation. Increase span of observation. So your four option, pick on the right options among the give the answer. So according to you, which option is best suitable for this question? An astronomical telescope has large aperture. Why? With the reason. You have four options. Among them, one of them option has the perfect region. Why astronomical telescope has large aperture? One is saying option A. I don't know. You tell me. What is the reason? Someone is saying, sir, what do you mean by aberration? Aberration is spherical optical defect. Optical defect in case of mirror or lenses, it is a type of optical defect that occurs in the lens or mirror. When the spherical surface does not form and fails to bring all incoming light rays, means this is a type of defect in optical mirrors or lenses. When incident ray is it's not going to meet on a particular point. So just this is not your right option. It's the advantage for you. Now you have to select among three of them. What is your right option? Yes. Someone is saying, yes sir, as you know, now we have to solve the question first and then we have to tell the answer. So as you know very well, the resolving power of a telescope, is equal to resolving power RT, resolving power of a telescope is equal to D upon 1.22 lambda. So D is nothing but what is the D? D is the diameter of the objective lens. Where D is the diameter of the objective lens. Diameter of the objective lens. Similarly, lambda is nothing but the wavelength of light. Is the wavelength of light. So this 1.2 is constant. So RT is relative power that is equal to D by lambda. So as you know very well, if you increase the diameter of the objective lens, you can decrease your resolution power. So the only reason is to increase the resolution. If you have to, what the question is asking, astronomical has large aperture. Yes, is the large aperture to reduce the wavelength, because if we increase the resolution, it is only possible when lambda is going to decrease. If the lambda is going to decrease, then only we can increase the resolution of our astronomical telescope. So to increase the resolution, this is correct option. Yes. So this is your correct option. To increase high resolution, because according to resolution power, these values 1.22 lambda, and this is the ratio. As you know very well, the relative power is inversely proportional with the lambda means wavelength. So if you increase the wavelength of light, so automatically the relative power is going to decrease. So whenever we have to increase the resolution, if the astronomical telescope has high resolution, then only it becomes reality, and it is equal to D. D is the diameter of the objective lens. As you know now very well. In this relation, RT is directly proportional to D. D is nothing but the diameter of the objective lens. Diameter of the objective lens is affect. Resolution power is directly proportional to diameter of the objective lens. Means if we have to increase the resolution power, then it is must to increase the diameter of the objective lens. I hope you understood very well. Now comes to another question. Now we are going to solve our another question, that is a glass, another question, a thin glass with the refractive index, refractive index 1.5 less as you have a thin glass, this is question number 8. A thin glass which has a refractive index question is going right. You have a thin glass which has a refractive index 1.5 less than optical power, minus 5 diameter in air. So optical power in a liquid medium has a refractive index 1.6 degree. So you have 4 options. So pick up the first option, minus 1 diameter. I repeat the question once again. A thin glass with the refractive index 1.5. This is the refractive index of a thin glass. Refractive index of glass 1.5. And then optical power minus 5 diameter. Optical power is minus 5 diameter in air. And one more thing, reflected index inputs means is the mean one. Let's suppose the mean one and mu 2. The mean one is the mu 2 is 1.6. So here the question is asking what the P2? What the P2? Means you have four values. V1 is 1.5. So the value of optical power is -5 in the similarly when you do reflected index to be 1.6, then in this case the P2 determine the value of P2. So there are four options. One diameter, C and D. So first of all you have to solve the question yourself and learn only one solutions. So as better as possible. So there are four options to copy. And that option only four. 35. So pick up the right options. So I can tell you one thing that whenever you establish a relationship between refractive index, focal length, and in this question and power. Power means what? Focal length similarly. Power means what? One of focal length. So if you have the relationship between focal length, refractive index, and radius of curvature, or the only formula that suits among all these three terms and create a relationship and establish a relationship among all these things, it is nothing but the length meter formula. So write on the heading using length meter formula. Length meter formula. So according to length meter formula, you know very well, length meter formula is nothing but 1/f बराबर mu minus 1. Mu means mu 2 minus mu 1 minus 1. 1/r1 minus 1. This is your next one. This is equation 1. Mu 2 means mu glass. This is the mu glass upon mu air minus 1. And mu lens 1/r1 minus 1. The air running. What is it? It is not air, yes, air. Sorry. It is not the lens, it is the air. New glass is you have the refractive index 1.5 to the value 1.5. And you know very well, refractive index of air is nothing but 1. 1 minus 1. 1/r1 minus 1. That's what is the equation number 2. So equation number 1 is this, and with the length meter formula in liquid medium. This is the length meter formula for now we have to put this value. So now we have to put the same formula for liquid medium. So write one line using length meter formula in liquid medium. Using length meter formula for liquid medium. For liquid medium. So as you know very well, 1/f is equal to mu g upon l minus 1. 1/r minus 1/r. So it becomes mu g upon mu l. The effective index of glass is the effective index of liquid. Is the L is not length liquid. So mu is numerical 1.5 and 1.6 minus 1. 1/r1 minus 1. So note up to here 1.6 minus 1.6 minus. So now we have to divide equation number. This is equation number 3. So now we have to divide equation 3 with equation number 1. With equation number 1. So now we have to divide equation number 3 with equation number 1 and we have to get medium air and let's put the air. So we can get 1 upon F means. Now divide equation number 2 with 3. So it becomes Fm, F medium upon F air. F medium 1.5 minus 1 upon 1.5. So it becomes 1.5 equation and left hand side there is nothing but minus 8. So on it the cost is around 1.5. So it is 1.5. So F upon F A means the total length medium upon the respect to A is around 8. And now power becomes minus 5. The contribution is nowhere. Is equal to. Similarly, you can solve this. Total length becomes 1 upon power becomes total length becomes this. Similarly, Fm is the total length of air and Fm is equal to Fm is Fa into 8 into 8. The value of Fa is something around minus 8 by 1. I hope it's clear. It is not minus because minus 8 is. This is nothing but a minus 8. That's minus 8. It is not minus 8 to minus 7. In grade is 1 in this. And it is cancelled out plus so 8.5. Now we have to create Pn. So put the box here. Power of medium. So in this case, as you know very well, mu upon Fm. Put the value of Fm that is 8.5 into mu. Put the value of mu that is 1.6. Again it's clearly 510 to 8 dot 81. How much it is power? Power is nothing but 1 watt. This is your final answer. So this question is very conceptual. You have to go step by step. Only then you can find the correct answer to this question. First of all, we can create the gas meter formula for medium with respect to glass. So mu is the glass. Effective index of 2 means effective index of glass. Mu1 is nothing but effective index of air. Minus 1. 1 upon R1 is 1 upon R1 minus 1 upon R2. Similarly, 1 upon F medium becomes the value of F medium becomes 1 upon 5 minus 1 upon R1 minus 1 upon R2. We can consider it as question number 2. Similarly, we can find the length meter formula. We can derive the length meter formula for the medium. So in this, mu2 is nothing but glass. Mu1 is nothing but liquid. So mu glass upon this is the ratio of mu glass effective index of glass with respect to the effective index of liquid. So with respect to minus glass with respect to liquid minus 1. So 1 upon R1 minus 1 upon R2. Similarly, put the value of effective index of glass and the value of the effective index of liquid minus 1. So it becomes this. Now we have to divide equation number 3 with respect to equation number 2. So right here, divide equation number 3 with respect to equation number 1. Sorry. So we can get this result. Have total length of medium to total length of air. This becomes this minus 8, and now the power of air is inversely minus 5. So you know the total length inversely relation with power. So Fa becomes 1.5. Similarly, F medium becomes Fa into 8. So from this relation, Fa goes here. So Fa is nothing but this is Fa upon Fa. So when we have to find the value of Fm is total length of medium, then Fa goes here. So 8 minus 8 into Fa. Put the value of Fa that is 1.5. You must say minus plus 8.5. So your Fm is 8.5. Now we have to, in this question we have to calculate the value of power. We have to determine the optical power. So optical power becomes mu upon Fm. So the value of mu that is 1.6 upon Fm is 8/5. So your answer is correct answer is 1/9. So your correct answer is option number B. I hope it is clear to you. The question is very easy. Only you have to learn the basic concept how to read the question. So one more question you have to solve. This question is very easy, I think. So this is your last question also. And later on you can. So in this question, write the question. If the refractive index of the material of a place is what? What is the question? If the refractive index of the material of the place is what? What? Refractive index of the material is what? A/2. So you have to find where is the angle of minimum deviation. You have to find the angle of minimum deviation. So in this question, whenever you have to find the magnitude of the angle of minimum deviation, then it is very easy. So as you know very well, you know the formula that is mu equal to sin A plus deviation minimum upon 2 upon sin A/2. So this is the formula, and mu is given for A/2. So substitute the formula value and get your answer. So in this question, sin A plus del minimum by 2 upon sin A/2. So as you know very well, what A/2 also done as cos A/2 upon sin A/2. So it got cancelled like that. So cos you know very well, cos 90 is equal to, you know very well, sin 90 minus theta is equal to cos theta. As you know very well, cos A/2. You can also write cos A/2 as sin I/2 minus A/2, sin 90 minus this is equal to cos A/2. So substitute the value of cos A/2 here, sin I/2 minus A/2, sin of A plus del minimum upon 2. So here sin got cancelled, so it becomes like that. So put the value and get your answer, that is del by 2 minus A/2 A plus del minimum by 2. So after solving this equation, you can get I/2 minus A/2. Yes, that is correct. So comes here, and 5 minus A upon 2 A plus del minimum. So to get cancelled, it becomes 5 minus A. So it comes here. It becomes 5 minus 2A minimum. So if the value of minimum is equal to, so whenever you have to calculate the minimum deviation that is equal to pi minus 2. That is the correct answer. I hope this is clear to you. So whenever you have to calculate the value of minimum deviation, that is it is equal to pi minus 2a. So you have four options like that: a, b, c, d. And you have to pick up the options. So you have pi minus 2a, pi minus 3a, pi minus 2a, and pi minus a, pi minus 2a, pi plus 2. So your correct answer is pi minus 2a, pi minus 2a. So in this question, the question is asking the refractive index of the majority of the prism is 4 alpha by 2. Is your base? So refractive index is 4 alpha by 2. And the question is asking about where is the angle of prism and the angle of minimum deviation. The question is asking the minimum deviation. When a ray goes like this, so the angle of minimum deviation. How much minimum deviation it is to be? A minimum. So I hope this is clear to you. So now this class we have to solve our 10 question, 10 PRQs of J-Mains. I hope it is very helpful to you. So thank you class. So next class we have to solve as many as questions as possible. Thank you so much. We will see you in the next session.